Today we're working on page 155, 1 through 49 odd, and it's just a review of functions. The basic definition of a function is no x value can be linked to two y values. So if I were to draw the x domain and the y range and filled it full of stuff, and then I just started connecting things, that is certainly a function. Every x is attached to a single y. But if I had multiple x's attached to the same y's, that's still fine too. And the way I like to think of it is a function links a person to the city they live in. And multiple people can live in the same city, but no person can simultaneously live in two cities, at least not entirely. I guess if the city line went right through the middle of your bed, you'd sleep in two cities, but you can't totally be within two different cities. So a non-function would be something like this, where a single x value is attached to two different y values. Now numerically it would look something like a series of points. So 4, 6, the number 3 is attached to -1, and 6 is attached to -2, and that's a function. No two points contain an x value that's going to more than one place. If I sent the number 0 to 6, that's okay. Person 4 can live in city 6, and person 0 can live in city 6. That's totally fine. The trouble you get into is when one person is linked to two different cities. So if I did 4, 3, that breaks the function rule. And that series of points is no longer a function. Now you might wonder, why do we care? Well, pretty much everything we do is based on the rules of functions. It doesn't appear to be very important in this class, but for the basis of algebra, we have to rely on the fact that the rules of functions apply. So the question is, what is it about these 2 points that makes this not a function graphically? If I were to graph these points, so 4, 6 would be right there, 3, -1 would be right there, 6, -2 would be there, 0, 6 would be there, and then when I graph that final point for 3, so of all my points, these two are the problem. So what is it about those that is a problem? And the answer is they fail the vertical line test. If I draw a vertical line and I drag it around the graph, does it ever hit 2 points? And the answer is right there, yes. Anytime a vertical line hits 2 different points, that is not a function. So if I were to graph a parabola and then draw my vertical line, does it ever hit twice? No. It hits once everywhere. It doesn't matter how far to the right I go, it will hit somewhere way up in the sky. And then you can see where the intersection is there, and when I go to the left, it's going to hit somewhere way up in the sky. So a parabola is a function. Things that are not functions would be a sideways parabola. A sideways parabola breaks the function rule all over the place. There are 2 y values connected to the same x. So that might be something like 1, 2 and 1, -4. Not a function. Okay. What if, going back here, I asked, what is f of 3? What does that mean? What does f of 3 mean? Any idea? If this is the function f of x, what would f of 3? It wants to know what is the function value when x is 3, or what is the y value when x is 3. So we would just go over 1, 2, 3, and then we would look up to here. So f of 3 is 8, meaning when I plug 3 into the equation, the number 8 comes out. Now I don't have the equation, I have the graph. So all I need to do is go over to x equals 3 and trace that up or down until I hit the graph, and then look at the y value. Does that make sense? Okay. The last piece of this is how do we evaluate functions that include multiple pieces? So, well, first we have to do this. If I had that same graph, and I asked for f of 3, and I ended up with, what did I say, 8? What if I said f of x is equal to -1? That's a different problem. What is that asking you to do? It says y is -1. Which x value creates a y equal to -1? So here is y equals -1. So that would be x equals -2 and +2. So you have to be careful when you do these. This problem was asking, if I plug 3 in for x, what is the y value that's associated with that? The next problem asks, if y is -1, which x values create that number? And in a parabola, there are going to be two answers most of the time. Does that make sense? Yeah. Okay. And then the last set, I'm going to take a picture of this one. We have a bunch of equations to look at. I killed the smartboard. That was cool. That doesn't happen. Okay, it's coming up. All right. Come on, smartboard. No. I should sing a song. There we go. Okay, on 35 through 49, you have a whole bunch of functions. Oh, can't quite see it. Go. Let's see if I can make that a little bit bigger for you. Okay. We have the function f of x, f of t, g of t, and g of x. So for number 36, it asks, what is g of -3? Capital G. So I'm going to take -3 and I'm going to put it in for the x's. So -3 squared is 9. 2 times -3 is -6. And 9 minus 6 is 3, and 3 minus 7 is -4. Easy enough? Well, they do get harder. Number 40 says, take g of -3 and subtract f of -1. Well, I already know what g of -3 is. It's -4. So this one spits out -4, and then I need to subtract whatever I get when I put -1 in there. So 4 minus -1 squared. -1 squared is 1. 4 minus 1 is 3. So I put a 3 right there, and 4 minus 3 is negative 7. Okay. And then look at number 48. Capital F of t plus 1 minus capital F of t minus 1. Because the formula contains a variable, my solution will also contain a variable. It's not going to be a number. I need to put t plus 1 in here. So I'm going to write 4 minus t plus 1 squared. And then I'm going to subtract, and you have to be careful here. I need to subtract the entire piece. So I'm going to put brackets 4 minus t minus 1 squared bracket. Okay, let's make sure everybody understands how that works. This is f of t plus 1. And we're going to subtract f of t minus 1. So this piece represents f of t minus 1. And I had to put it in brackets because I'm subtracting it. Now, you could just use parentheses, but if there are parentheses and two sets of parentheses happening at the same time, I like to draw them differently so I don't mess it up. Okay, can you do this in your head now? Oh, that parenthesis goes right there. So I'm going to get 4 minus t squared. Then what? What are you going to get? What's that? 2t. I'm going to get 2 copies of t times 1. So t times 1 plus t times 1 is 2t. Plus 1. Okay. And then I will subtract, bracket, 4 minus, what do I get when I multiply t minus 1 by itself? It's the same as the last one, except it'll be negative 2t. So t squared minus 2t plus 1. Now, I need to distribute the negative. So distribute, distribute, distribute. And I'm going to distribute this to get negative 4 and distribute that to get plus. So on the left side, 4 minus t squared minus 2t minus 1 minus 4 plus t squared minus 2t plus 1. Oh, I don't need any brackets anymore. Now we just combine like terms. 4 and negative 4 are opposites. Negative t squared and t squared are opposites. The negative 1 and the positive 1 are opposites. And I get negative 2t and negative 2t. And that gives me negative 4t. So that is the result of taking capital F of t plus 1 minus capital F of t minus 1. Any questions on that? Okay. Get to work.